Popularized in the 1920s and used heavily ever since, the bulldozer is a clear offspring of the crawler tractor. Used in conjunction with other earth-moving vehicles, the bulldozer is a powerful and necessary tool utilized in almost every construction site in the world. So, how bulldozer is made? Raw materials. Bulldozers, characterized for their immense blade and versatile track, are comprised of many structural, hydraulic, and engine assemblies. The core body of the bulldozer, consisting of the mainframe and undercarriage, is primarily fabricated from low-carbon structural steel plates and a giant casting. The cab contains many glass, rubber, and plastic components which enhance the ergonomic feel of the machine. Supplying the power for the dozer and its various systems, the engine contains many high-strength steel parts, which endure high operating temperatures. The other necessary components, the blade, powertrain, and various systems components, are formed from structural and high-carbon steel. The manufacturing process. Manufacturing begins with engineering prints and drawings taken from a computer-aided drafting (CAD) program that outlines the method of construction for each component part. Some of these components will then undergo heat treating, annealing, or painting after their respective fabrication cell, sub-assembly line, or machining center step. An overhead conveyor system will then transport the pieces through the rough paint and lift them to the main assembly line, where they arrive in time to be assembled. Mainframe core. The mainframe core is cut from steel plate and structural shaped, so that it easily resists high-impact shock loads and torsional forces normally incurred by the dozer. The main structural skeleton, formed through the welding of steel plates to machined casting, is comprised of two boxed-in rail sections connected to the main casing. The fabrication is performed in a fabrication cell, where the burned plate arrives ready to be mounted into fixtures and welded to the stationary central casting. The frames are then transported by overhead crane to different stations, are welded on as a support for the other components of the bulldozer. Once completed, the frame is rotary sanded on all plated surfaces and sent to the paint booth and the main assembly line. Diesel engine and transmission. At the assembly line, the independently manufactured diesel engine and transmission join the mainframe. The engine is usually purchased completely assembled as it is a complex system with machined components that can be used in many different vehicular applications. The two are connected by a long shaft and supported by couplings and bearings. The transmission is then connected to a series of gears and differentials to comprise the rest. By mounting on pads previously welded to the frame, the engine transmission assembly can be bolted directly to the base on the main assembly line. Radiator and additional assemblies. On the front of the bulldozer, an engine casing is mounted to support the radiator and hydraulic lifting cylinders. The radiator, another finished assembly, will then sit between the engine casing and mount to the front drive shaft. Connections can then be made to attach water lines from the engine to the radiator. Additional assemblies for the hydraulic, lubrication, cooling, and fuel systems are also constructed at other locations and purchased as a finished assembly ready to be fastened directly to the engine or base. Large component assembly. As the entire assembly of the frame, engine, transmission, and line groups move along the main production line, larger assemblies and components are brought in by overhead cranes, overhead conveyors, automatic guided vehicles, AGV, or lift trucks. Final assemblies. Once the dozer has been outfitted with its primary components, more hoses, electrical lines, and fluid lines are attached at fitted connections. Items such as the batteries, which are connected to the starter on the engine, lie underneath a cowling in a compartment located near the engine. Lights, one of the last items installed on the dozer, will be placed in a number of different areas and connected to their power source. In addition, hand or guard rails and foot pegs are bolted on the frame which complete main line assembly. Paint. Applied manually with spray guns, the final paint booth will deliver paint to any area not blocked off with paper or plastic wrapping. The paint dries quickly and the bulldozer will move to the next station where decals and trim are applied by hand templates. Fluids. Various fluids are added, and the vehicle is then sent to a testing station where the operation of all systems is mechanically verified and recorded. The vehicle is transported from the manufacturing site to a staging area for customization and shipping. The completed bulldozer is shipped on a flatbed trailer and is ready for field operation upon arrival. Byproducts, waste. Waste produced by the manufacturing operations may include machining coolants, oils, parts cleaning detergents, paint, and diesel fuel. The United States Environmental Protection Agency places strict regulations on manufacturers to are disposed of in a proper manner. Companies contract a waste removal firm to recycle most of the liquid waste. Metal chips and shavings are recycled and sold to scrap dealers in an effort to reduce waste. The future. Bulldozers consistently undergo component design modernization efforts, and innovations appear inevitable. Improvements in cab comfort and diesel engine efficiency will be the driving force for many of these changes, while design and operational changes will be limited to individual components. In spite of the fact these enhancements in both the manufacturing process and streamlining of material flow will probably not change the face of bulldozers, costs may improve. Therefore, as a useful member of any earth-moving team, the bulldozer will continue to serve a unique purpose in building construction, waste management, and many industries. In this video, we will take you through the complete manufacturing process of mini excavators. 1. Design and development. The first step in the manufacturing process of a compact excavator is the design and development of the machine. This involves the creation of blueprints and drawings of the excavator by engineers. The designing part also involves creating a prototype of the machine which is then tested for its performance. Here are the vital considerations that engineers take note of when deciding on the design of an excavator. Decide the size and weight. The size will determine how much digging power it has. The weight will determine how easy it is to move around. Type of engine. Two types of engines that can be used in a mini excavator: gasoline and diesel. Gasoline engines are less expensive, but they are not as powerful as diesel engines. Diesel engines are more expensive, but they are more powerful and durable. Type of tracks. There are two types, steel and rubber. Steel tracks are more durable and can handle more weight, but they are also more expensive. Rubber tracks excavators are less expensive, but they are not as durable and cannot handle as much weight. Types of attachments. The most common attachment is the bucket, that is used to scoop up soil, sand, and gravel. Other attachments include a backhoe, a trencher, and a grater blade. Once the design process is complete, the next step is to build the mini excavator is welding the frame. 2. Welding the frame. The first thing that you need to know is that there are two types of welding processes used in mini excavator manufacturing. These two processes are MIG and TIG welding. The main advantage of MIG welding over TIG welding is that it is much faster. However, the downside is that it produces more fumes and welds are not as strong as TIG welds. Furthermore, the manufacturers cut the pieces of metal that will be used. The metal must be cut to the correct size and shape. The next step is to join the pieces of metal together. This is performed by welding them together. The last step is to add any reinforcements that are needed. Reinforcements are added to areas that are under a lot of stress. This helps to prevent the frame from breaking. 3. Assembly. The next step is to assemble all the parts of the mini excavator. This is done by welding, bolting, or riveting the various parts together. Steps in assembling mini excavator. Add the tracks. They need to be placed on the frame so that they are level and even. Install the engine. It is important to make sure that the engine is properly secured to the frame. The mini excavator engine is usually added last because it is the heaviest part of the mini excavator. Attach the bucket. The grading bucket for a mini excavator is one of the most important attachments to a mini excavator. Attach the backhoe. The backhoe is another important attachment. It is used to excavate large amounts of dirt and soil. Attach the trencher. It is a long, narrow attachment that is placed on the back of the mini excavator. Also, it's vital to attach a trencher attachment for the mini excavator. Attach the grater blade. The grater blade is used to level off areas of land. It is a large, flat mini excavator blade attachment that is placed on the front of the mini excavator. After all of the attachments have been added, the mini excavator is now ready to use. However, before directly sending them to the marketplace, it is important to test them. This is also to ensure that the mini excavator is able to withstand the wear and tear of construction projects and is safe to use. 4. Testing of mini excavators. Once the mini excavator has been assembled, it is then put through a series of tests to ensure that it is safe and effective. The mini excavator tests include load testing, performance testing, and safety testing. Once the excavator has passed all these tests, it is then ready for use.